Good morning. I'm going to be giving an update on California halibut. We've been working with the species since the 80s. Personally, I've been working with them since 2007, about a decade, and we're getting back into them pretty much as we were asked to give an update on the species. So the name says halibut, but it is a flounder. It's the largest species, largest of the genus. It's a highly valued species that supports an important commercial and recreational fishery along the Pacific coast of the United States. And as I mentioned, has been reared experimentally since the early 80s with some limited commercial efforts done in Mexico. The broodstock are easily collected hook and line. If you know the people that are fishing for them, they're easily collected. The only issue bringing them into the lab is trying to get them to transition onto sardines and squid. It's, they prefer the live fish, and so you kind of got to transition them over a couple months. But once you get them transitioned, they feed very well. The tank densities for broodstock are pretty comparable to other marine finfish species. About 1.5 to 4 kilogram per cubic meter. The tank volumes that we've used range from 10 to 44 cubic meters. The smaller tank volumes, as Cadell et al. Found in 1990, anything below 10 to 12, you start seeing some skittish behavior. They'll slam against the sides of the tanks. We've also seen some reduced viability and poor spawning in smaller volume tanks, some unfertilized eggs, so there's probably a behavioral aspect to the deeper, larger diameter tanks. For the work that we've done, unfortunately we've never had photoperiod or temperature control, but there is it has been shown that they will respond well to that and be able to spawn, be able to shift them in cycle. For the spawning, they are broadcast spawners. The age of sexual maturity for the males is 2 to 3 years, females 4 to 5 years. Both volitional tank spawning and strip spawning has been done. We haven't done any strip spawning. We obviously prefer to have volitional spawning occur. We've slowly, this year we've started to do some more hormone therapy, working with Ovaplant and HCG, which we've had some varying success with. Again, we are working under ambient conditions, so spawning occurs between 15 and 22 degrees Celsius. Anything, as the temperature gets to about 14 to 15 degrees, the fish will start the spawning behavior. At about 21, 22, everything will shut off. It was found in the literature, again, 15 to 16.5 degrees Celsius is what keeping the tanks at, and if you're controlling temperature. And the photoperiod is between 10.5 and 13 hours light. And so this is a kind of an indication of what we're seeing for a couple years. Broodstock are spawning between January and roughly July or August, depending on the water temperature. They're fairly highly fecund. The viability is pretty representative of what we've seen for the last 10 years. It's low, so there's a little bit of research there that needs to be done to improve that viability over the years. But once you get eggs to hatch, there's good hatch rate, good survival to first feeding. Larvae are very robust once they hatch, and the hatching usually takes 24 to 48 hours depending on water temperature. And survival first feeding usually occurs 2 days after hatch rate. Our basic larva culture, we usually stock at 50 to 100 eggs per liter. We set the water temperature at about 18 degrees Celsius. Photoperiod for the larva culture, another area of research that we need to focus in on. We have done 24 hours light. We're 12-12. There's some thought there that if the photoperiod is affecting some pigmentation issues, which I'll get into in a little bit. Our light levels have been between 1,000 and 1,500 lux. Again, might be a little high for the species, and so we're working towards getting at that over the next year or so. They do need green water for from 3 to 17 days post-hatch. We've got fully weaned fish by 35, and settlement will occur between 30 and 35 days post-hatch. And prior to settlement, we were getting survival rates of 70 to 80% in the larval phase. So that larval phase is fairly easy for the species. We're seeing some issues once we get them transferred into our juvenile rearing systems. And the prey regime is pretty standard. Rotifers for about 2 weeks, transition them right on to second instar, and then co-feeding for about 10 days with the formulated diet. And so back in 2007, 2008, we developed an integrated larval system. It's basically a rack system. We have a nursery incubators on the outside that has their own recirculating system. The incubators are attached to the racked raceway system, which has its own filtration system. And one of the best things about this is that it's a high-intense system, but you can transfer the larvae fairly easily into these raceway systems. And so we want to try to transfer the larvae right as eye migration happens and prior to settlement, because if they settle in your incubators, there's going to be, they're basically going to stick to the sides of the tanks. And so you end up transferring them by lowering the water volume to the raceway that you want to transfer the fish into, push water in from the raceway system, and all your fish go in there. It takes about 24 to 48 hours. So the system's available, or the system has been designed, it works well. Unfortunately, we changed our priorities, and we took the system down, but it is there. For juvenile culture, we believe that raceway culture is the best way for high density. You can really pack them in. We do see some heavy losses during this stage, mainly from aggression, from fish that haven't settled to fish that have settled. We do see a high level of malpigmentation, from 50 to 90%. We believe that has to do with both the culture environment and nutrition. We're reaching 1 kilo in about 2 years. 3 years, we're reaching about 2 kilograms. And as for other Paralichthys species, the females grow the fastest. In terms of feed availability for flatfish, no commercial broodstock diets. We're feeding them sardines and squid with a vitamin premix. For micro diets, we've used the Skredding line. We also use Otohime. So there's a lot of need for diet development for flatfish in general. And for disease and prevention, there's a need for diagnostic viral disease, vaccines for bacterial control and parasite control. For ectoparasites, we've had some broodstock losses due to cryptocarrion. We've seen some endoparasites. The bacterial agents, we've had some broodstock losses due to photobacterium, but all treatable. The issue with the flatfish is that you don't really see clinical signs until they're almost gone, because they do just sit on the bottom. So you have to be really proactive on those disease agents. We use Parasite S as well as peroxide to treat these different types of bugs. In terms of the market, currently there's only a wild fishery. The total landings in California are about 250 metric tons, valued at about 3.3 million. 1.1 of that comes from Southern California, which is roughly about $13 a kilo. If there is a cultured California halibut in the market, they would be competing with Harame, which is the olivaceous, and they're getting an estimated value in the live market about $22 a kilo, about 2 to 4 kilograms. And then just to give you an idea of our growth rates, the orange lines are what the wild data for California halibut. The blue lines are the wild data for the olivaceous. The black circles are the actual data that we've gotten over the year. The black line is the fit from those black circles, and so we're pretty much on the same growth curve as the wild fish. The Harame market in Japan is about a 1.5 kilo. They're getting there in 12 to 18 months from their cultured fish. We believe that there's potential for halibut to kind of get to that place, but we need a lot more research to be able to improve that growth rate. And so while it's technologically feasible, to be able to get to the commercial side, we have a lot of research to be able to start doing, to be able to realize that, all the way from egg production. I mean, the main goals of the research are to improve that growth rate and to be able to get to market size a little bit faster. So that's all female populations. We need to improve that pigmentation and a lot of nutrition work to be able to reach these goals. So for right now, I'd like to take any questions. Questions? Yeah, go ahead.
When you're rearing these fish in the tanks, is there any sediment or anything on the bottom? So you're just straight onto the fiberglass?
Yeah. We have done for almost 10 years ago. We did put some sand in the paint for the broodstock. So the question was there any sediment in the tanks with these fish? But we haven't used any. We have put sand in the paint, but for the broodstock, we noticed a little bit more irritation on the ventral side, some more, I guess, some sores, and we shifted back to just normal fiberglass tank, and they seem to be fine in that environment. Go ahead.
Do you think there's an issue in the marketplace with the pigment abnormalities? Is that costing you money as a grower?
If you're going to the live market, I would say yes, and probably even if you're selling them whole, I would probably, especially to the Asian markets, I would say yeah. Right.
Kevin, do you have any problem with skewed sex ratios? Mostly all males?
Yeah, it's a good question. A lot of the research shows that early in larval development, if your temperature is high, but in the 18 to 20 degree range, you're going to skew to all male population. We have seen that. In fact, the last group that we ran a couple of years ago, when we euthanized the fish, it was 95% male, and that is an area of research that we need to get at if we're going to really continue to focus on the species, especially for commercialization.